So it's now 2 o'clock sharp. So I suggest we do open this workshop on AI in the fire safety and security industry. So welcome to everyone. I see that we already have 33 persons connected. This is still growing. So um, maybe we can wait 1 more minute as I see the number of attendees is increasing. So first, in order to open this workshop, I just want to mention that this is a workshop that has been intended by and for the Euralarm members. I'm Benoît Brooks. I'm technical manager for Euralarm, and I will be the moderator for this session. This session is intended not to be a webinar, but truly to be a workshop, meaning that we expect to see it as being interactive. So you will have the opportunity to ask questions, to intervene, to also to explain maybe some of your experiences you have with artificial intelligence in fire safety and security. And so your question, you can ask them via the chat or just raise your hand, and then we will leave you the speech. We will allow you to speak. So this is the principle. You have the agenda here on the screen. We will have a welcome and introduction by our president, Peter Mita. Then a presentation from Agoria on AI technologies. Then I will introduce you to the AI Act shortly. Then is proposal and explanation on AI security application and how to ensure that standards are adhered. Then a case study related to fire detection, and then continue with an open discussion with all of you, all the members, before closing that workshop and hopefully having some suggestion and some ideas for further activities. So now I will leave the word to our Euralarm president, who kindly accepted to introduce this workshop. So thank you very much, Peter Mita. The floor is yours.
Thank you. Good afternoon, everyone, and welcome to our workshop on AI. Today, I think it's clear we are at the forefront of a technological revolution where artificial intelligence, or AI, is changing industries and everyday life. AI is the product of years of research and innovation and is now shaping how we use technology, create new ideas, and define the concept of work. During our last section meetings in Lisbon, members raised a question to the marketing committee. Could we organize something for Euralarm members on AI in the context of the fire safety and security industry? Rather than focusing solely on the details of the AI Act, the idea was to create a collaborative workshop where members could share experiences, discuss real-world applications, and learn from one another. It's great to see such strong interest in this topic, and I'm confident that today's discussions will provide valuable insights to all of us. I encourage you to actively participate, exchange ideas, and make the most out of this opportunity to explore AI's impact on our industry. During this workshop, we will look at the role of AI for our industries. Artificial intelligence has the potential to revolutionize the fire safety and security industry. And with advancements in machine learning, data analytics, and automation, AI is clearly opening new possibilities for faster threat detection, predictive maintenance, and enhanced decision-making. As we explore AI's potential, we must recognize the standards guiding its use. These guidelines help ensure ethical practices, reliability, and safety. A key example is, of course, the AI Act, which regulates AI technologies to guarantee safety, ethical utilization, and protection of fundamental rights. It does that by sorting AI systems by risk level and sets clear requirements for transparency, accountability, and compliance for developers and users. The European Commission is actively fostering excellence in AI to strengthen Europe's competitiveness. Through investments in research, innovation, and regulatory frameworks, the EU aims at ensuring trustworthy, human-centric AI that supports industry growth while maintaining safety and ethical standards. By promoting collaboration between businesses, policymakers, and research institutions, Europe is positioning itself as a global leader in responsible AI development. In this workshop, we aim at exploring the current state of AI in the fire safety and security industry. We will discuss how AI is already being deployed, its impact on the industry and our members, and what this means for the future. Additionally, we will examine Euralarm's position on AI and how we can shape its responsible adoption to benefit our sectors. Through shared experiences and discussions, we hope to gain valuable insights and define a path forward together. Again, I encourage you to participate in today's discussion, ask questions, and bring your own insights. Together, we can explore how AI can be harnessed to create a safer and more secure future. With that, I'll hand it over to the next presenter. I think it's Ferdinand. Thank you very much.
Thank you very much, Peter. I think we first have some slide or questions. Martin, what's the plan now? Should we move to the Agoria presentation first?
Sorry, Benoit. Yeah, my microphone was on mute. Sorry. On the screen is a QR code and a link to the website slido.com. There's a number behind the hashtag. If you choose either the QR code or the website, then you can start a survey, and that survey starts with a question on the words that come up when you talk about AI.
Martin, we see the slide from Agoria, not the slide with the QR code.
Sorry for that. Then it should be visible now.
Okay, thank you. Thank you, Martin.
That makes it a little bit easier. Okay.
Yeah. So please scan this QR code, and then you can have access to the questions and answer to them. So those are questions related on the general aspect of AI technologies, just to get an overview on your knowledge and just to break the ice with those questions and have an overview on the attendance today. And so please scan this one. Then the first question should appear on your smartphone, on your browser, and then we will, I think, in real time have the flavor of your answers. I see in the chat that there is no question.
No,
Martin, the Slido is open for questions, not for answering a question, but
Oh, for answering a question. Okay. Let me see if I can fix that moment. Otherwise, Benoit, it would be good to step forward to the presentation of Ferdinand and see if I can fix this. Yeah.
Yep. Okay. So then I will give the floor immediately to Ferdinand Kazir. Ferdinand is a Senior Business Group Leader Digital for Agoria, and he will lead us briefly through the AI technologies. So Ferdinand, the floor is yours.
Okay, thank you. So good afternoon, everyone. My name is Ferdinand Kazir from Agoria. So I don't know if you know Agoria, but it's the Belgian Federation of the Technology Industries. And I'm more in charge within Agoria of all AI programs and initiatives since 2018-19. So I have been asked to present in 10 minutes the AI technology. So it's quite a challenge to do that in 10 minutes. And to do so, I've chosen to base my presentation on a document from the EU IT community supported by the European Commission. They have a document on the taxonomy of the European AI ecosystem. And they mention in that document 8 different AI capabilities. They call it more AI capabilities. But I think it's a good starting point to speak about AI technologies. So they mention, of course, computer vision, but also computer audition, linguistics, robotics, creation, forecasting, discovery, and planning. These are the 8 categories that are mentioned in that document. And for my presentation, I propose to go in these different capabilities and to see how it could be applied also in your domain. I just have to mention that I'm not an expert in fire safety or security, but I try to find on the internet some good examples for these different capabilities. Good, let's start with computer vision. I think that's the most obvious one for you. I think you are all active with this kind of technology since years. It's of course based on image and video, and these AI technologies they can do different things like object detection or detection of persons. Also image captioning, segmentation and generation, and text recognition in complex scenes. I think this is quite easy one. You all know this one. And as example, I think I have this one. It's it's the Linde Group in Mexico, and it was installed by a Belgian-based company, Arani. They have developed intelligent video analytics solutions for critical environments. So in Mexico, in the Linde Group, it's a very critical environment. I think they produce nitrogen, so it's highly highly sensitive, of course. And this camera can detect smoke detection technology. And that's how they work with that. So that's the first example for fire safety. Another example also in Belgium with another camera from ASIC. That's to detect intrusion on a big site, on the Total Oil site in Belgium. It's the largest polymer production site of Total in Europe, actually. And thanks to these cameras, they can detect the presence of individuals approaching or illegally crossing the site's perimeter, and at day or at night, and this under all conditions. So this is another example of computer vision. That's an easy one. Then we have also computer audition. That's another AI capability, and the signal here is an audio signal. And not only spoken language, but also environmental noises. For example, for machine monitoring and anomaly detection, it is quite useful. Some examples for this one. This is a set-top box from Free. Free is a French telco, and this set-top box can detect specific noises to detect fire alarms, and so to prevent also people for this. Another example for more safety or kind of safety is noise pollution detection. This was done by Nokia in a city in Belgium, in Genk. And they monitor and analyze vehicle-induced noise pollution. So they utilize data from connected microphones and they combine it with cameras. So it's sometimes they call it also fusion technologies, where they combine different sensors to detect here in this example vehicles exceeding noise thresholds. So it's another example to enhance urban safety and of course also quality of life. The next AI capability, computer linguistics or NLP, natural language processing. I will come back also later in the presentation on this one. But of course, here you have mainly text or language representations that is used in these technologies. Well-known examples are bot interaction and conversations, sentence and text generation. I think now we have quite a lot of examples of this one on the market. Examples that I found for the fire safety, these are Chinese researchers, and they have developed a system that integrates BIM, so building information models, with NLP to automate the compliance checking of fire safety regulations. So this system parses building models and then translates regulatory documents into machine-readable formats. So that's the first example. Another example from Proximus, that's the Belgian telco. They utilize NLP-powered AI tools in their security incident response system. So the tools analyze large volumes of security logs, but also emails and chat communications to detect suspicious activities, such as phishing emails or unauthorized access attempts. So that's for NLP. Another capability mentioned in that EU document is advanced robotics and control. This is also something I think it's quite common in your domain, your sector. An example is Shark Robotics, well known from the fire at Notre Dame. They used that robot to, I mean, it's really built for very complex fire disasters. These robots are equipped with cameras and sensors, and it delivers also real-time data, enhancing situational awareness for the firefighters. Another example also by Axel Robotics in Belgium. They produce underwater mine identification engines, and it's used by the Belgian and the Dutch Navy. So these technologies are equipped with high-resolution video cameras, and this is also where AI can work for. Then we have creation, and of course, with generative AI, that's now a very important AI capability. Maybe I will go immediately to one example. It is used, for example, by One Bonsai, a Belgian-based company, and they have set up fire safety trainings in virtual reality. So for virtual reality trainings, they use generative AI to build very responsive and realistic environments to train people. So These are very well-known scenarios, of course, to use the generative AI for VR or XR solutions. Then I have 2 or 3 capabilities, the 3 last capabilities: forecasting, planning, and discovery. I will take these one together, actually, because this is a huge domain. Forecasting is about demand prediction, price prediction, default prediction. So it's mainly based on historical data to detect trends and patterns in the data. When you look at discovery, also customer segmentation, it's also a lot of data, sales data mainly, or machine sensor data that is used. And then also planning for optimal routing. And you can see this one is also using maybe sometimes more classical AI. And for this one, I have the last slide here. And it's kind of overview of all these different techniques that are used in the AI world. So it's a very broad world. And you see, I've put myself expert systems here on top because it is still used, and it's more the classical AI where the data is provided by the experts. It's a very robust and transparent use of AI. Of course, it exists since more than 50 years, 60 years even. And then you can see in this Venn diagram the different techniques that exist: supervised learning, unsupervised learning. These are both part of machine learning, but you can also see where the other capabilities are positioned in this Venn diagram with computer vision and robotics using these different AI techniques. You can see just next to the natural language processing, the transformers and large language models, and these are more the ChatGPT-like models. But it's a mix, of course, of NLP, of unsupervised learning, of deep learning. So you can see all these domains are really entangled to each other's. But it gives, I think, with this picture, a good overview of the different AI methodologies that exist. So there was a very short overview. Maybe I have here's a last example using more this data analytics. This was for Securitas, but it was not the underwater mine identification, it was something else. It was the risk prediction service. So they analyze historical incident data to forecast the likelihood of future security events. So you maybe have heard that in the States, the police is using AI to detect if a crime could be a crime incident could be possible or not. Well, Securitas is using the same technologies for future security events to predict, to forecast the likelihood of future security events. And this very proactive approach enables organizations to implement data-driven security measures and mainly to optimize the resource allocation. So that's how they use it. Maybe as last slide, if you are interested, we have on our website different courses, free online trainings, and feel free to follow these courses. So I'm open for questions.
Thank you very much, Ferdinand, for this general presentation. So do we have any question? I see, Paul, you have raised your hand. So Paul, please.
Thanks, Benoit. Ferdinand, what you mentioned in the beginning, the AI used for fire detection and for security, but video cameras are already used for a very long time for security applications and for fire. So why are they now suddenly AI? And in the past, we did not talk about AI. Is it just because we have now the word AI? Was the technology always used, or is there really a difference between, let's say, the classic cameras for security, which do object and movement detection, versus the camera systems which use AI today?
What I've seen when I prepared this presentation, the cameras today are using also different captors, the different sensors. So it's not only image, but it's also combined with noise quite often. So that's more fusion AI, like they call it. This is more recent than the classical approaches that we know since years, I think. It also collects context data. That's what I've seen, meaning that it can give more context-related data or data analysis to take some decisions. I'm not the expert in cameras, but I think now they can do much more with the data that these cameras collect, than they can do before. They can, I think, from what I've read the previous days, they can detect, or they can analyze the context of the images much better than it could be done before. Maybe somebody can complement what I say here, but this is what I've seen.
Thank you.
Yep. Thank you. I see another question in the chat from Thomas Littes. So Thomas, if you want to explain your question or to bring your question orally, what is exactly the definition of AI in respect of machine learning?
Yeah, so machine learning is a very broad domain. And machine learning is the definition. It's very difficult to give a definition like this. Machine learning is mainly used to it exists since years, since I think the 70s. So it's nothing new. And the date. I mean, you can oppose this to the classical expert systems, where you have first the rules that have been set up by experts, and to go from the rules to an output. With machine learning and deep learning, you start from the output. Actually, you put it in the system, and this will define the rules. Actually, so the logic has been reversed a bit, mainly with deep learning then. Yeah.
Okay.
I don't know if that is clear.
Okay, and now the micro is on. Now I can also talk. Yeah, that was exactly the question I wanted to ask. You know, you in your last slide you showed that machine learning is covering a lot of these subjects too. And is it then that the decision making is creating something new, where you say the artificial intelligence starts, or you know, where does the machine learning stop, and when does the AI start?
Well, machine learning is part of the AI domain, so it's a subdomain. Machine learning is a subdomain of the AI, so you cannot say where stops the AI and where begins because it's machine learning is just part of the AI. It's one of the domains of the AI, but it's a big domain in the AI world. So maybe you can specify a bit more your question then.
It's okay. That's fine. I think it's going too deep otherwise. That's fine. Thanks.
Yeah. So most probably the answers to such kind of question can be found in the online lessons that you have on your Agoria website.
Yeah. Mm-hmm. We have actually one online course. It's totally free to join that course, and it's a bit more technical. The first one, it's about 3 hours, 4 hours maximum, and there we give a good overview of different AI techniques and technologies. Yes. So.
Okay, and I see on the chat also remark try ISO IEC 22989 and OECD website, so where you can find certainly also answers to such kind of question. I see a message also from Soria Sorozzano, if you want to speak to explain your view, or it's going into more details on that answer. I do have a more let's say general question about AI, because you remember, and you certainly have followed that the recent Paris summit on AI, where the Commission President Ursula von der Leyen stated there is a distinct European brand of AI. So from your Agoria perspective, how would you summarize this European brand of AI?
Yeah, it's a very huge debate, of course, meaning that, of course, we can see there are a lot of investments in the US and in China, for example, a lot of budget. And the question is how Europe can have a third way in AI. I think, and we think it's quite, I mean, it's maybe not the smartest move to just follow what the US and China is doing, but how can we in Europe invent another way, a third way for AI? And that's, I think, what Ursula von der Leyen also mentioned. And of course, since more than 7 years, we have a European program on AI called Trustworthy AI. So they want to really build trustworthy solutions instead of just solutions without guardrails. And this is what she means. We want to build robust, reliable, as transparent as possible AI solutions. And yes, this is something we can do. Sorry?
Nu hebben we eigenlijk 4 buizen in doorsnijden, maar we zouden daar 2 van maken.
Martin, we have some background noise from your side.
Yeah.
Hey, this is Martin.
Maybe I can just share another point on that question, because it's an important question. What we have seen, or what we think, is that in Europe, we should focus on smaller models, because we always speak about the big language, the big LLMs, and of course they are also important. But for the industry to work on smaller language models, it's much more efficient. It's less energy consuming, and you have also less hallucinations in these smaller models, as the data that is used for these models, the data sets are much smaller also. So we think Europe must invest much more on these smaller models. And when I say smaller models, we usually speak about models, small language models with 2 to 30 billion parameters. That is small. Because if you look at, for example, Meta with Llama 3.1, they have 406 billion parameters. If you look at DeepSeek, the Chinese model that came out in January, I think they have 680 billion parameters. And if you look at OpenAI, they don't give, they don't publish their figures, but people think it's about 1,800 billion parameters, so 1 trillion, 0.8 parameters. So these are the big models. So the smaller models up to, I would say, 30 billion parameters. These are models that first are more reliable, less energy intensive, and also models that you can more and more run on local devices. And this is something we also see at Agoria, that more and more industrial companies would like to have AI solutions on premise, not in the cloud, or as less as possible in the cloud. And this is something you can do with these smaller models. So it could be also the third way of Europe to invest in these smaller models. Yeah.
Thank you. Okay, that's a great answer, and I think well in line with what Euralarm is willing to do and willing to investigate. So, in order to move forward, could we have an overview on the answers on Slido, Martin? Is it possible to show us the picture of what are the first words that comes in mind when we think about AI? I don't see the answer coming in.
So I have some trouble with finding that one back. Sorry, this is the picture. I don't know if you can see it.
No, for the moment, nothing is shared.
It should be visible now in the chat. Is that correct or not?
Yep. Anyway, I suggest we move forward then with the next presentation. And I think it is my presentation of the AI Act. So the goal is to briefly drive you through this new regulation. If we can go to the first slide, please. Okay, so it is a regulation that has been published recently, so last July, laying down harmonized rules on artificial intelligence. It's the first ever comprehensive legal framework on AI within the world. So the very important element of that regulation, of course, as for any regulation, is the scope. And more specifically within the scope is the definition of the AI system that has been very difficult to develop and that took a long time before they landed when they agreed with a definition, which is the one that is there in the red rectangle. It is quite a long and difficult to understand definition, where you can see that there are several words that I have highlighted in bold characters, and those are the keywords in the definition. And hopefully, the European Commission has published a guideline on how to understand those keywords, and this is accessible on the Commission website. And so I strongly encourage you to download that guideline because it does explain with some examples those keywords. And so it helps to understand what is in scope and what is not. It's of course not totally comprehensive, but it's certainly a first step to help you understanding that complicated definition. Next slide, please. Then the regulation is structured on a risk-based approach from minimal risk to limited risk, high risk, and unacceptable risk. So the bottom is minimal risk, or let's say no risk AI, where there is no legal requirements. It's just an invitation to adopt voluntary codes of conduct. So this will be certainly for probably most of the AI systems. Then there are AI systems with limited risk and those that interact with natural persons, where there is a requirement for informing the user that they are interacting with an AI system. So that's a second level with Article 50. Then the very important one now is the high-risk AI system, where so there are definitions of what high risk is. There are examples. There is an annex describing that, and it is important because for that category there are essential requirements, and a conformity assessment procedure to be followed in order to place such kind of AI systems on the EU market. And then there are the unacceptable risk AI systems, and those are prohibited in the EU, and it's the purpose of Article 5 of the regulation. And this Article 5 is already applicable since this month, February 2025. It is applicable, and those banned are really prohibited, and you cannot place them on the market anymore. And there is a guidance provided by the Commission in order to understand what are those prohibited AI practices. And you can download it in order to understand whether what you are placing on the market and what you are using, whether they are acceptable or not. Next slide, please. Then focusing more on the high-risk AI, which are the ones that are allowed, provided that they comply with essential requirements. This is an important part, as I said, and the essential requirements can be summarized as follows with the several bullet points: risk assessment and mitigation, quality of data sets, logging of activity, detailed documentation, information to the deployer of the AI system, human oversight, and then robustness, cybersecurity, and accuracy. So those are the main essential requirements if you want to place an high-risk AI system on the EU market. In addition, there are some specific requirements for general-purpose AI models, but as far as I know, those are not really the topic for Euralarm. And then if you want to put such a high-risk AI system on the EU market, there are several steps to be followed. So when you have developed your AI system, you have to undergo a conformity assessment procedure to demonstrate that you comply with the essential requirements. Possibly you have to go through a notified body. You have to register your standalone AI system on an EU database, and then you have to make a declaration of conformity and let's say affix the CE marking on your AI system, or at least mark it CE. And then you can place it on the EU market. If you make some substantial changes that could affect the compliance with the essential requirements, that you have to go back to step 2. So it's quite a usual procedure for an NLF regulation, which is in place with including the CE marking. Next slide, please. So this gives you an overview of the applicability of the regulation, and you see that the AI bans Article 5 from February 2025 are already applicable. Then the obligation for general purpose AI systems will be applicable as from August. Then all the rules except the one for high risk will be applicable as from August 2026. And then the rules for high-risk AI systems, so the rules in Annex 1 will be applicable as from August 2027. So you still have time to make your compliance assessment procedure according to the essential requirements. Next slide, please. Besides the AI Act, the European Commission was willing to put the stakeholders together and assess how the provisions of the AI Act can be fulfilled. And then they set up the AI Pact. So in order to promote best practices, sharing among companies, encourage voluntary early adoption of the regulation, and create an advisory board comprising national associations and relevant public entities. So it's really a forum where there is an exchange on practices on how to satisfy the different requirements. Very recently, last week, there was a webinar about that, which was about a particular article on AI literacy, where some stakeholders explain how they intend to satisfy the requirements on AI literacy. Euralarm is now represented in that AI Pact, and this will certainly be followed by reports to the sections or horizontal compliance committee. Next slide, please. And then, of course, it's quite usual for most of you, when there is a regulation under the new legislative framework, there is a standardization request, and it is the M593. that has been offered to Senselect JTC 21, and they have 10 deliverables to provide. Initially, the deadline for those standards was end of April, but this has been prolonged to end of August this year. So JTC 21 is working on that. It is, let's say, quite challenging to meet even the postponed deadline. So it's unsure that harmonized standards will finally be adopted and cited in the official journal. But JTC 21 is still working on those. And I think this closes my presentation on the AI Act. And before moving to the presentation on AI security applications, we have some questions on Slido. So does it work now, Martin?
If everything goes well, it should work. There's a Slido button on top of your screen. If you click on that, then the Slido questions will appear on the right side of your screen, and you can give your answer there.
Okay. So
Okay.
see, yeah, I see, at least on my smartphone, I see the answer, which is let's say there is quite consensus on the answer.
Mm-hmm.
But now the answer has disappeared on my screen. So
oh, sorry, this it should be this one. Sorry for that, Benoit. Let me have a look where it is.
So could I suggest we move then now to the presentation on AI security applications and how to ensure that standards are adhered. And I want to introduce now Frank Rothman, working for Bosch Sicherheitssystem in building technologies and in the product development related to cloud-based services. But also Frank is a convener of IEC TC79 Working Group 12 on video surveillance systems. And so I invite you now, Frank, to make your presentation. Thank you.
Thanks, Benoit, for the chance to present here. I will share my screen. Hopefully you can see my screen here. Make you some smaller. So yeah, thanks for the intro. I'm the convener of our video surveillance work group, now at IEC, before at Senelec, European organization. 15 years ago, we have been lifted, let's say, to international level, and work still on the same topics, but now on international level. You know our work as EN standards, but they are now as well published worldwide as IEC standards. Just let's say to start, let's say at our traditional domain, this is video analytics, let's say, starting at perimeter protection for critical infrastructure, right? Intruder detection in outdoor environment. But of course, not limited to that anymore, especially with the new technologies, AI, LLM, to open even more applications and more domains to this kind of topic, video analytics. And just to point to one of our standards, it's a 62676. This is our series as well, available in Europe. As I said, the part 6 deals with video analytic performances, how to test it, right? And just looking at one example, how this is dealt in Korea. For a long time, they do certification test on for different applications, just to name, like these are more the traditional ones for security, but as well they are having certifications for fighting, detection of fightings, or even fire in, I'd say now, public places. Similar picture, a little wider for China. They have even a more extended certification scheme there with different applications. I will hurry a little bit, make it a little shorter, my presentation. And I mean, you know most of these applications. So what is it there for? So usually these certifications are done on a public set, right? You can configure, train your detector, and then in a private test house, the certification is done with a secret similar video sequences. And for this, let's say we have, the outline set in our part 6 standard. Jumping over. Now, of course, all this is influenced heavily by all the AI innovation, LLM innovation. So today it's not only, let's say, the edge camera, the edge device, the server at the edge on site, which does different video analytic jobs. No, now you're connecting cloud analytics, public ones, or let's say on your dedicated servers in the public cloud domain with AI capabilities to what your system has done before locally on site, on-prem. So what is a benefit? Of course, having a big server with AI capabilities behind the little cheap embedded device on the edge, you gain, of course, a lot of performance, right? And usually, let's say, even if you have AI edge devices, AI-enabled edge devices on-prem, the one in the cloud, which is, of course, much bigger, much more expensive, you have performance improvements of, I'd say, just a number, by 20 times, right? So whatever's done on-site by guards, by security operators, is much more easier. They can do, let's say, 20 times more jobs, saving as well costs. Let's say this is for the traditional topics, not talking about new areas of applications, which I might list some on. If there are any questions, please interrupt me, right? I will otherwise run through the slides and be available, of course, for questions some later. Just to give you examples, like traditionally, I will show a short video. You have this in video surveillance, perimeter detection in a scene. There is, let's say, a light from a car passing here. The edge camera, possibly with AI, is thinking, oh, that's an intruder moving in the right speed with the right size along that perimeter. And for AI, you can easily suppress that one. So there are different use cases here, or traditional applications, which I will not go into to save some time, but we can come back anytime. Very easy example as well. There are a lot of solar farms, meanwhile, in Europe, right? And you want to detect intruders. Traditional analytics cannot really distinguish moving objects, people from animals, right? So here you only can apply, let's say, video analytics if you have it combined with an AI detection. Other applications are, right, you have guards walking around, and they would trigger, of course, false alarms in all those scenes. With AI, you could identify them as a guard, as a security car, and just get that load from your central security station away. Right. So this have been more the traditional applications, right? But opening up, of course, more applications, which you can now with AI approach, right? You have, let's say, detecting a gun in a bank environment, right? Or in a high school in the US. Because you can now identify better, detect better those weapons. As well, let's say other application, fuel station with spilled fuel, or even if it's later on the fire at a fuel station, equipped all with cameras, so you can now easily apply those image feeds to cloud AI, being able to detect these complicated situation and scenarios. I would now do shortly one step even further. So this has been, let's say, around maybe for the last 5 years or even longer, AI at the edge in the cloud for video security application, video surveillance application. Now, with the big language models, the large language models, you can even do more with images. They have a basic understanding of image video scenes by itself. So what you can do now, and I mean this already arrived in our industry, you can ask that large language model some really fundamental questions, like in this case, just to make an example, is there something wrong in the office room, right? You can prompt it for this image and it will return, yes, there appears to be an issue. A person is holding up a large toy gun in an office environment, which is inappropriate and potentially alarming behavior in a workplace setting, right? So that's interesting. They were seen, we do a test here. It's not a real gun, it's even a toy gun. Pretty interesting. So here you can see really the capabilities of these large language models, which have been explained before. Opening up a lot of opportunities. Paul, you have a question, I think.
Yeah, Frank, I'm always confused with because you see LLM in a lot of AI applications coming back, and if you look at the abbreviation, it seemed to be related with language, at least the acronym. But then you see it in all kind of data analytics coming back. What is the connection between that, let's say the LLM, the language module, and analytics for video? And I saw it also in other applications where they often talk about using LLM for data analytics.
Yeah. I mean, we talk, of course, here about the vision, the image understanding, but of course, you as, let's say, integrator installer would, of course, specify your problem, your interest with natural language, right? So you are asking or specifying your, let's say, question, your request. It's a prompt, right? We're prompting today in natural language, which, I don't know, it's not like you need to calibrate a camera for 1 week as an expert, one in a country, right? You're the expert. No, you're prompting it in your natural language, whatever language it is, German, English, French. And so here is the connection there, although it's working, let's say, on with image understanding this way.
So it's referring to the question you ask and not so much referring to the video analytics you do. Is that the correct statement?
Yeah.
Okay.
Yeah.
Okay, thanks.
And I think for video analytics, everybody's trying to write this the right terms and definitions to find them. Probably, I don't know, in 1 year we'll call it probably different. With let's say we all getting familiar with these new toolings. Exactly.
I
And
see
now,
another hand raised by Soria.
please.
Yes,
Please.
Anna, my name is Anna. Thank you.
Oh, sorry.
Thank you so much. This idea was very, very interesting for me because I never thought about to combine somehow safety and ChatGPT, for example. So it's really nice to see this example. But I have a question regarding our specific field. How you can deal somehow with the privacy, let's say, of the images, because I mean the camera is placed in somewhere, and maybe the client or the people there is not able to provide the images as easy as to chat GPT. So how you can deal with this kind of problems?
Anna,
Thank you.
thanks a lot exactly for that question, because this leads to my last slide. We here in security industry, let's say maybe especially in Europe, because well, we have heard everything about the AI Act and our, let's say, being scared by the cloud itself, offering public access. And here's exactly the question. We have all that big innovation with AI, maybe in the last 5 years, now with those large language models. How can we bring that, I say now as Euralarm, to our customers, to our market finally? And here I think it doesn't really work. As well, the cloud detectors for critical infrastructure, etc., those parameter, you will not connect, I say now, a nuclear power plant to the public cloud. You need a different initiative. And here, let's say, I'm trying to let's say, get the right views, discusses here. If let's say government cloud, cloud limited to certain users, I think it already has a name. It's called the European Sovereign Cloud, is the right way to lift all that innovation as well to the major part of our customers, to say that last, which have high security concerns and are just not a shop around the corner, which have probably no problem connecting to the public cloud where, let's say, our AI services are hosted. But here we need a different approach. Yeah. Because otherwise they will not get an application which is 20 times better than being on-prem. Right. And the interesting is, of course, we have it in video, but I think we all share that challenge wherever you are in safety or in security, any domain. And this is actually, let's say, yeah, where we might work together all together.
Frank, I assume you're referring to that European-wide government cloud, or is that something else?
No, there's a new initiative. Not sure if this is done by only a few companies. I know it more from the Americans.
Okay.
They have the Gov Cloud, government cloud. They have a certification program. It's called FedRAMP. And just last year, a similar initiative was started in Europe. So if you are, let's say, European government or are in critical infrastructure, you can connect to that cloud and ask for services, right? And you as let's say, manufacturer or industry in the security industry, safety industry, could offer services there, which are not limited to just one industrial site, no, which are offered to any site. Because let's say if you are providing an AI detector, right, an AI cloud, this is crazy expensive, right? This costs, let's say, 5-digit numbers per month. So you cannot use that in a single site. It needs to be shared by 100 factories, by 100 energy plants. Because you cannot deploy it to the site. And here, maybe we have a way where all what's offered in the public cloud could as well be lifted to our customers in the critical infrastructure.
Okay, thank you.
Frank, I do have a question because you put there on the screen the possible new Euralarm initiative. What would be your recommendation for a first step for an action by Euralarm? How would you see that?
I mean, this is a new young idea in Europe, and I would say the interesting is if this new initiative is really interesting to our partners, customers in the critical infrastructure, at government, etc. So if they say, yeah, we have no problem connecting there because it's a European sovereign cloud and it's made for us, then of course it's interesting to us here as a security industry in Europe, and we could create interest from that one, and then look for partners trying to bring applications to that sovereign cloud, which is of course as well an extra step. So I think is this something really interesting for our partners, our customers? Yes. And then we could get together here at Euralarm to say, okay, let's start with a few partners to provide services there for security and safety.
Okay, I think a very good topic to bring into the sections for debating. Yeah. Would you have further slides or?
Well, this is more or less what I have there.
Okay.
Exactly.
Thank you very much. I would have several other questions, but I think in order to give the opportunity to our last presentation to take place and then hopefully an open discussion, I would now leave the floor to NACD with a case study on the use of thermal imaging sensor technology with Danny Lee, who is Operations Director at NACD Limited, a member of BSIA. So Danny, the floor is yours.
Thank you. Can we have the first slide, please? In the UK, it's become clear that many residential high-rise buildings have serious fire safety defects associated with their original construction. In serious cases, the entire cladding system may need to be replaced or proper fire compartmentation installed. There is a predicted end date of 2035 for completing cladding remediations. Next slide, please. About us, we install and maintain access control, door entry and video surveillance systems. Most of our customers manage high-rise residential buildings. Many of these are social housing. The case study location is a housing regeneration scheme that was built between 2010 and 2017. Our customer manages several buildings on the scheme and has an on-site concierge office from which they remotely monitor security systems and other building management systems. Next slide, please. We were approached by the Housing Association, who wanted one of the cameras that monitored an access controlled door on a roof terrace garden to be moved to the edge of the building so they could overlook an adjacent building. They told us that the building had been identified as needing remediation works, but this would take time. And following a risk assessment by a high-rise building expert from the Fire and Rescue Service, control measures were needed to manage the risks in the interim. These were improvements to the fire detection and alarm system and adding a waking watch of fire marshals to patrol the building. the risk assessor had also noticed that the control room monitored cameras in and around the building, and they recommended that some of these cameras could be relocated, repurposed to help them manage the risks. Next slide, please. So having understood the requirements, but concerned about the privacy impact of using cameras to monitor public space and private space, we asked the customer if they would consider using a thermal imaging camera instead of the video cameras. And this was because the thermal sensor would only display temperature gradients and not show identifiable images of the persons. They consulted with the Fire and Rescue Service high-rise building expert who approved the change. When we were looking for suitable equipment, we noticed one product used an algorithm to identify long-range forest fires. We asked the manufacturer how this algorithm would behave if we used it to monitor a building. They confirmed that it would identify patterns of heat, flame and smoke and generate an alert that could be received by a video management software application. We then went back to the customer and asked them if they would consider adding the video management to enable the algorithm so that the operator could receive and manage the alerts. They again consulted with the high-rise building expert who agreed. Next slide, please. These are images of a roof installation. Our head of technical is also on the call. If anyone has any questions about the equipment, how it was used and configured. Next slide, please. So these images show the camera images. In fact, when this system went live, it immediately went into alarm, and we thought that it may have been because the camera needed to be calibrated or configured, but in actual fact, it detected immediately one of the residents lighting a barbecue on their balcony, which is obviously a very dangerous thing to do given the condition of the building. So it proved that the system was being effective. Next slide, please. This is a overview screen of the video management system that the operator sees. If a camera went into alarm, that image would pop up onto an alarm management monitor, and there's also a alarm management tab in the video management system that would allow the operator to manage, respond, and close or escalate alarms. Next slide, please. So the outcomes and benefits, I think, first of all, we need to think about the limitations of the system like this. It cannot replace the traditional fire detection and alarm system. In fact, while it was being deployed, the fire detection and alarm system in the building was being upgraded and enhanced. It couldn't replace the waking watch, the fire marshals patrolling the building. In fact, at the same time, the number of marshals was increased, and also a control room was added so that their activities can be coordinated. It can't replace a trained control room operator either. Again, the control room was created with more video feeds were put in, but there was still a human being at the end receiving the alarms and making the decisions. Next slide, please. So what did we achieve with it, and why was it of a benefit to the customer? Well, it allowed them to monitor parts of the building that a traditional sensor couldn't see or couldn't detect. It provided situational awareness for the waking watch of areas that they couldn't see on their patrols. It also reduced the workload of the control room operators and sped up the incident response times. Next slide, please. Yeah, so additional benefits outside of the intended use. They managed to identify a suspicious vehicle parked late at night in a dark area of the estate with its engine running. So they could send a security guard to challenge them, and they found that they didn't have a legitimate reason to be there, and so they were moved on. They also, on another occasion, identified an emergency vehicle entering the estate, and they looked kind of lost. They made contact with the people in the vehicle, who were an ambulance, who were trying to locate a resident who had a medical emergency, and so they were able to access the building and contact the person with the emergency, and also that reduced the amount of time it took them to receive treatment, which was also a very important thing. This project was delivered around 6 years ago. It used relatively inexpensive equipment that employed very basic algorithms. So yeah, in no way can it be considered state of the art, but I think it does indicate the potential benefits that could be achieved using the more powerful AI that's available today and connecting it to more sensors and more systems. Modern security and building management systems generate and log a lot of information that's only viewed at service intervals or post-event. This could be used to look for patterns and generate alerts pre-event, so applying the principle of prevention. So that was a very brief case study, but yeah, any questions? Myself and our head of technical Tia are on the call.
Thank you very much, Danny. So is there any question in the audience?
Danny, you said the project was established 6 years ago.
Mm-hmm.
Is there still work? Is it still operational? Has it been run as a pilot or?
It's only with one customer, one housing association, and it's always been at the recommendation of their local fire and rescue service high-rise buildings expert. So we've only ever deployed it when they've identified a need. As the remedial works take place, the systems are either being decommissioned or they're being redeployed to carry out conventional security management duties.
Is there any development still ongoing? Because it looks like it doesn't look, but the last 6 years there has been a lot of new developments and new tools became available, which makes data analytics, let's say, give you much more options than you had in the past. Is there still development ongoing in this project, or is that at this moment just as it is and?
Yeah, we're just using the systems as they are, as they've been approved by the local fire and rescue service. But yeah, you're correct in I think you're saying that there's potential there, isn't there, to develop this further. We're just an integrator into this term, so that would really be maybe for the manufacturers of the equipment and the software vendors to consider.
Okay, thank you.
Any other question from the audience?
I see there is a remark, Benoit, from Jeanette.
Yes. Mm-hmm. A remark on the chat, yes. Important to challenge the ways in which we traditionally work with security. Yeah, certainly. Then a question from Thomas. How difficult was it to get the agreement of the tenants to install a camera?
Tio, do you want to take this one?
Yes, hi. Well, it was mainly down to the housing associations to inform them about what's going to happen. All residents have been informed generally within few weeks before the actual installation, and when concerns were raised, the housing associations had provided them with images that everything is privacy masked and reassured the residents that's not the case. The cameras are not there to monitor them, is to monitor the building itself for safety reasons.
Thank you. I do have a question about the learning process, or more on the data sets, because you have mentioned on your slide that you had to train, like for any machine learning systems, you had to train your algorithm. I would like to understand how those data sets are chosen. Was it a data set very specific to your use case or to your algorithm? Or can we envisage generic data sets for, let's say, thermal fire detection that could be used to train algorithms from different manufacturers? because with the AI Act, we know that there are requirements on the accuracy and on the unbiased data sets. So how does that work? How does that work practically?
Sorry, Theo, yeah, over to you.
Yeah, so the devices themselves have a set of smart function that you enable it, and they basically, the way it works, they have a configuration flow. It starts at the smart plan. You choose it to do only heat and heat elements and temperature elements, and then the camera will focus all its resources on that only. And from that point, there is a calibration step as well, where we set the temperatures, minimum and maximum, and then the camera starts to basically create a pattern of what are the temperatures when it's like the sun reflects from metal and stuff. It learns those locations, and then it just keeps a track of the actual patterns of temperature itself. And it also has a few smart features that can detect actual smoke, so it can differentiate on a specific area. It can be set to see, oh, there's smoke coming out, that's something wrong. It will trigger an alarm.
Okay. Any other question? Or maybe more general remark or other contribution from the audience? What do you perceive with those presentation as possible further Euralarm actions in the field of AI? Any suggestion, any statement, any wish? I see one hand raised. Michael Esman, please. You are muted.
I unmuted him.
Okay, thank you,
Michael,
Paul.
please go ahead.
Good afternoon, everyone. One of the opening slides today showed China's version of AI interpreting the fire code. Is there any sort of plans for something like that in Europe?
Who can answer to that question? I don't see anyone.
Then probably nobody has the answer. But I think it's a very good example how it shows how the technology is moving forward. I think that's for sure what you can conclude from that.
Frank, do you have something on that?
Well, no. Just wanted to join here. No, not to that topic. Sorry. Yeah.
It was very brief, the actual sort of the slide. So it'd be interesting how they was actually doing that. Were they doing that through cameras? How was that actually being performed? Be interesting to see a little bit more insight into what that fire code was, but also how they were achieving it. Yeah, that's about it, really.
Yeah, it was on your slide, Frank.
No, I think it was the intro by our Belgian colleague, by
Ferdinand.
Ferdinand, it was, yeah.
Ferdinand example, yeah. Okay. Oh, yeah, sure. Yeah. So Ferdinand, are you?
Christian shared the link in the chat.
Okay. Okay, so you will have the link for further investigation there. Okay.
Right. Thank you.
Anything else? Any question or suggestion? European sovereign cloud mentioned by Frank. Yes, so please ask your question orally. I assume you can unmute yourself. Murem?
Now he can.
Now we
Yes,
can.
good
So
afternoon.
please speak up.
Can you hear me?
Yes.
Okay, my question is regarding the European sovereign cloud mentioned by Frank. So currently, a lot of essential suppliers have the problem of being having data into public cloud, and they need to use private cloud. Will this solve that problem, and also the problem that the US American cloud providers, they are obliged to provide data when the US government asks for them, and that is also the main issue. Will this solve that problem?
Probably a question for you, Frank.
Yeah. Well, finally, like now being maybe working now 10 years for cloud solution at Bosch, like with exactly that challenge, right? How do we get those interested parties into the cloud to offer them better services? So yeah, let's say I wanted to share a link, but it's as well a big American company, like we talk about Oracle and Azure and AWS, right? And you might be right if, let's say, the US authorities ask for data, they will give it, right? Also, this is a local European setup. And this is the question, right? This was actually my question. Does this fit to the governmental requirements of critical infrastructure? Is this the right answer, right? Do we need to wait for a decent European initiative? Then this is actually my question. Is it right now the day, the time to start that one? And then second of us, is this interesting for us, our industry? Do you see the same challenges, let's say, as me in my little office here? And would you be interested to do, let's say, together that step, right? Yeah. And if this is not the right answer, as you said, no, we are scared by this big US providers, then it's too early, right? And then we need to wait for the right answer and say the time is not now. But of course, we're postponing all that technology from this very interesting partners, right? And would go with the easier verticals, the easier sectors. Well, then it's a shop, then it's retail, then it's whatever, but not critical infrastructure, with, I think, is the guys we deal more or less on a daily basis with, right? At least here at Euralarm, and not that much the easier verticals. So this is exactly my question. Is it time now? And is this the right answer? Or do we still need to wait?
Good question. We shall see. But yeah, so the problem is that a lot of standards in Europe, they demand private cloud, and yeah, that's a lot of companies are waiting to move to public cloud, but it's not possible at the moment.
Yeah. Yeah.
Thank you for your answer.
Thank you. We are very close to the closing of this workshop. So, Paul, may I ask you for a short wrap-up of what we have learned today?
Yeah, and I think, Benoit, a few takeaways from my side. First of all, thank you to the presenters for sharing the information. It's very interesting for those people who thought there was not a lot of activity in the security and fire industry on AI. I think this presentation and sharing the information has shown there is a lot of activity. Which I want to make one remark on that. It looks like video is the only one, the only example we really touched, and everybody who presented outside Benoit Youth explaining the AI Act was related to video and video analytics, which seems to be the most obvious connection with AI. As it was mentioned by Ferdinand, Agoria has a very nice AI training on the website. It's free. It has 48, I think 43 or 48, more than 40 examples of AI, and only 2 or 3 of them are directly related with fire and or security. And it's very nice to look at other examples also, not so much directly related with video or related with the direct fire and security, but also with operational improvements like in services and service visits, better planning. The examples are all accompanied with videos from 5 or 6 minutes, which gives you a very clear explanation. So I really, if you want to look a little broader than what we have seen today, then I think that's a very good source. And also, you saw a number of questions in the Slido where I also didn't know all the answers. There was also a very good explanation of terminology which is used in the AI and AI developments. So I think that's my main takeaway, Benoit. And I think it would be good to in the upcoming section meetings to spend a few minutes and see in what areas we can share more information and collect more information, but also every time when I talk with members about AI, there is still also a very gray area what AI is and not. It's very clear what AI is, where it is, but there is also that gray area where, let's say, the technologies which were already under development are now connected with AI and with new tools, and I think it would be very good to understand how that will move forward. So far from my side, my takeaways, Benoit.
Thank you, Paul. So now for the closing remark, I would leave the floor to Peter. If you can provide us with your closing words.
Yes, can you hear me?
Yes, we can hear you.
Yes, thank you, Benoit. Of course, I would like to echo Paul in thanking the presenters, Ferdinand Cazier, Danny Lee, and his colleague Theodore, Frank Rothman, and of course the Euralarm technical staff that has organized this very interesting workshop. I think there's a long way ahead for Europe to catch up with other countries across the globe on this key topic. But this is the challenge that we must embrace. And of course, from the standpoint of our sector, is also, I believe, a great opportunity. So with that, I hope that the workshop was appreciated by everyone and useful. I certainly appreciated, replying to the polls. That was quite innovative. So thank you for that, Martin. And with that, again, thanks a lot to all presenters. And I wish everyone a very pleasant weekend. Thank you.
Thank you, Peter. Again, thank you to the presenters and thank you to all the audience for your participation, your questions, and the interaction. And special thanks to Anja and Martin for having organized this workshop.